Look up at those soaring spires, those impossibly high arches, stone fingers stretching toward the heavens as if trying to touch the divine. For centuries, these medieval cathedrals have stood as silent witnesses to history, their beauty unquestioned, their purpose clear. But what if there's more to their grandeur than meets the eye? What if these sacred structures are not just houses of worship, but vast stone libraries holding scientific secrets, encoded messages, and forgotten knowledge waiting to be uncovered? Imagine walking through those hallowed halls, running your hand along ancient carvings, and realizing every curve, every angle, every shadow was placed with intention. These cathedrals weren't just built to inspire awe, they were designed to whisper secrets across time. Think about the precision it took to align a cathedral's windows with the solstice sun, casting beams of light that ignite specific altars like celestial spotlights. Picture the way sound dances through the vaulted ceilings, creating harmonies so perfect they feel supernatural. Consider the sacred geometry etched into every stained glass rose window, patterns that mirror the mathematics of the universe itself. This isn't just architecture, it's a masterclass in science, art, and spirituality woven together. The builders of these cathedrals didn't have modern tools or textbooks, yet they crafted buildings that defy explanation, blending astronomy, acoustics, and engineering in ways we're still trying to decipher today. So how did they do it? What hidden knowledge was passed down through guilds of stonemasons and whispered between master builders? And why did they go to such lengths to encode these secrets in stone? That's the mystery we're unraveling in this journey. From the sacred geometry hidden in plain sight to the celestial alignments that turn these cathedrals into giant astronomical clocks, we're diving deep into the lost science of the medieval world. This isn't just about history, it's about rediscovering a time when science and faith were inseparable, when the pursuit of divine truth walked hand in hand with the laws of the natural world. So let's step inside these stone giants together and listen to what they've been trying to tell us for centuries. The answers might just change the way you see the medieval world and the foundations of our modern science forever. These cathedrals weren't just built to house congregations. They were designed as mirrors of the cosmos itself. Picture standing at the center of Chartres Cathedral's labyrinth, your feet tracing a path that mimics the celestial dance above. Every twist and turn wasn't random. It was a carefully plotted journey reflecting ancient beliefs that heaven's order could be captured in stone. Medieval architects saw their work as sacred geometry, using mathematical principles like the Fibonacci sequence to shape columns, arches, and even the spacing of windows so they harmonized with nature's own patterns. Look closely at the rose windows and you'll find ratios echoing the growth of seashells, the unfurling of flower petals, the very spiral of galaxies. The floor plans of these cathedrals often aligned with constellations, turning the nave into a terrestrial echo of the Milky Way. At certain times of year, sunlight would pierce through strategically placed openings, illuminating specific carvings or altars like a divine clockwork. Chartres' labyrinth, for instance, wasn't just a meditative path, it was a mathematical pilgrimage. Walking its 11 concentric circles was believed to symbolize the soul's ascent through celestial spheres, a physical echo of the medieval understanding of the universe's layered heavens. Even the cathedral's dimensions held secrets. The distance from the western facade to the labyrinth's center matches the height of the vaulted ceiling, binding earth to sky in perfect proportion. What's truly astonishing is how these builders worked without modern tools, yet encoded cosmic truths into every measurement. They understood something we've since forgotten, that sacred spaces could be bridges between the tangible and the infinite. The next time you see a cathedral's ribbed vaulting, think of it as a starlit sky frozen in stone, each arch a constellation waiting to be read. Take a step closer to those breathtaking rose windows, and you'll find more than just stained glass. You'll uncover the fingerprints of the universe. Medieval architects didn't simply design these masterpieces. They wove the golden ratio into every curve, every petal-like division of light. This mathematical constant, approximately 1.618, appears in nature from the spiral of seashells to the arrangement of leaves on a stem. The builders knew this wasn't just a number. It was a sacred key to beauty, balance, and divine order. With nothing more than a compass and straightedge, they transformed stone into harmony, creating windows that glow with the same proportions found in the human face, the branching of trees, even the structure of DNA. The vaulted ceilings above you aren't just engineering marvels, they're geometric hymns. Ribs stretch upward in intersecting arcs, tracing patterns that repeat the golden ratio in their spacing and curvature. These weren't arbitrary choices. When sunlight floods through the windows, it doesn't just illuminate the space. It activates hidden relationships between the angles, casting shadows that align with carved symbols at precise times of day. The entire cathedral becomes a living equation, a three-dimensional prayer in stone. But the real genius lies in the puzzles hidden underfoot. At Canterbury Cathedral, intricate floor tiles form geometric labyrinths that double as secret teaching tools. Walk their paths and you're retracing the steps of medieval scholars who saw geometry as a language of the divine. Some tiles encode unsolved problems, complex constructions solvable only with Euclid's principles, left as challenges for future generations. Others form star patterns that mirror celestial maps, turning the floor into a silent observatory. These weren't decorations, they were classrooms without walls, where every line held meaning and every intersection whispered secrets of the cosmos. What's astonishing is how these builders achieved such precision centuries before modern mathematics. Their tools were simple string, chalk, and faith, yet they mapped the heavens into architecture. When you stand beneath a rose window, you're not just seeing colored glass, you're witnessing a bridge between earth and sky, built by hands that understood geometry as God's native tongue. The next time light pours through those ancient panes, watch how it paints the floor. Those aren't random shapes, they're the same patterns that govern the turning of planets and the beating of human hearts, frozen in stone for eternity. Now picture this: a single shaft of sunlight piercing the stained glass on the summer solstice, crawling inch by inch across the cold stone floor until it alights upon a hidden carving of the Green Man, his leafy face suddenly ablaze with golden light. This isn't magic, it's celestial choreography perfected at Amiens Cathedral centuries ago. Medieval builders engineered these moments like divine playwrights, turning sunlight into sacred theater. Only on the longest day of the year does the light strike that exact spot, awakening the carved face from shadow, as if the earth itself whispers, "Now." How did they achieve such precision without laser levels or digital calculators? The answer lies in patience etched into stone. Master builders used something far more reliable than technology. They used the sky itself as their blueprint. By tracking the sun's path with simple tools like gnomon sticks, vertical rods that cast shadows, they mapped its arc across seasons. At Amiens, they carved trial marks into the walls, adjusting angles over years until the solstice light hit its target with split-second accuracy. Some scholars believe they even embedded secret markers in the floor, invisible to casual observers but guiding sunlight like a celestial conductor's baton. The Green Man isn't the only hidden actor in this solar drama. At Chartres Cathedral, a single beam illuminates a lone nail embedded in the floor on the summer solstice, a subtle nod to Christ's crucifixion. In Bologna, sunlight traces a path along a meridian line to mark noon on specific feast days. These weren't accidents, they were theological equations where architecture became a bridge between heaven and earth. But here's the real marvel: these builders accounted for atmospheric refraction, the way sunlight bends as it passes through Earth's atmosphere. Without telescopes or modern physics, they compensated for this distortion, tweaking angles so the light show would remain flawless for centuries. Some cathedrals even have error carving slightly misaligned designs that prove they tested multiple positions before achieving perfection. Stand in Amiens on that solstice morning, and you're not just witnessing a play of light. You're seeing a conversation across time, a whispered secret between the builders and the cosmos, preserved in stone and sunlight. The next time someone calls these cathedrals ancient, remind them their architects didn't just build for their own age. They built for ours, knowing one day we'd look up and finally understand. Walk into the choir of Lincoln Cathedral, where monks once chanted prayers that seemed to rise effortlessly to the vaulted ceiling, not by chance but by design. Medieval builders crafted these spaces as acoustic instruments, where every curve and column worked in harmony to carry sound with supernatural clarity. The choir stalls weren't just placed randomly, they were angled precisely to reflect voices toward the congregation, ensuring even the softest whisper could reach the farthest pew. This wasn't architecture, it was physics disguised as devotion. Take the so-called singing pillars in certain cathedrals, massive stone columns that hum with musical tones when struck. At Aachen Cathedral, gently tapping specific pillars with a mallet produces clear, resonant notes, as if the stone itself were tuned like a giant xylophone. Scholars believe these weren't accidental. Builders may have hollowed out sections or selected stones with specific densities to create this effect, turning the very structure into a hidden instrument. Some theorize these pillars were used to teach Gregorian chants, with each note corresponding to a pillar, turning liturgy into a tactile experience. Then there's the mystery of the whispering galleries, spaces where a murmur spoken against one wall can be heard clearly dozens of feet away, while St. Paul's in London is the most famous example. The technique dates back to earlier medieval prototypes. At the Basilica of Saint Denis in France, a low word spoken near the apse curls along the curved stonework, arriving at the opposite side with eerie precision. The builders understood how sound waves could hug concave surfaces, designing spaces where secrets could travel without echo or distortion. But the true masterpiece lies overhead. Ribbed vaults weren't just for show, their undulating surfaces scatter sound waves in ways that eliminate dead spots, creating a uniform acoustic soup where every note lingers just long enough to blend. In places like York Minster, this means a choir's harmony doesn't just fill the space, it hovers, as if the building itself is singing along. Modern acoustic engineers still can't replicate this perfection without digital modeling, yet medieval craftsmen achieved it with ropes, plumb lines, and an intuitive grasp of how sound dances on stone. Next time you stand in a cathedral, try this. Clap once. Listen as the sound shimmers upward, fracturing into a dozen echoes that fade like footsteps in heaven. That's no accident. It's the ghost of a master builder's calculations still resonating through the ages. Stained glass wasn't just decoration in medieval cathedrals, it was alchemy frozen in light. Some panels shimmer with colors so vibrant, so impossibly rich, that modern scientists still puzzle over their recipes. Take the famous Blue Virgin window at Chartres, its sapphire tones so deep they seem to drink sunlight. This wasn't just crushed glass and dye, it was a chemical masterpiece. Recent studies suggest medieval artisans might have infused their creations with gold nanoparticles, tiny flecks of the precious metal suspended in the glass to create those fiery reds and purples that glow like embers. How did they stumble upon nanotechnology centuries before microscopes? The answer lies in their workshops, where theology and proto-chemistry blurred into one. Gold wasn't the only secret ingredient. That legendary blue in Chartres windows, it defied European glassmaking for generations. The hue came from cobalt, but not just any cobalt. Trace elements in the glass match ore from Persia, a region locked behind trade routes guarded by Silk Road merchants. Some historians believe monks or crusaders smuggled tiny parcels of the precious powder back to Europe, hidden among relics or sewn into hems. The cost would have been staggering, making each blue pane worth its weight in treasures. Yet the effect was undeniable. When sunlight strikes that glass, it doesn't just pass through, it transforms as if the sky itself has been bottled and set in stone. The real mystery is how these artisans achieved such precision without modern lab equipment. They worked by trial and error, recording recipes in coded manuscripts that read like spellbooks. One surviving text describes melting glass with gold salts, then reheating it until the metal blossomed into ruby hues, a process modern chemists now recognize as nanoparticle formation. Another mentions grinding sapphires into the mix, though scholars debate whether this was literal or allegorical. What's clear is that these craftsmen weren't just mixing pigments, they were manipulating matter at scales invisible to the naked eye. Even the placement of these windows hints at deeper knowledge. The Blue Virgin sits where dawn light hits hardest, ensuring its color washes over entering worshippers like a divine embrace. Reds and golds often cluster near altars, their warm tones symbolizing the fires of faith. This wasn't random artistry, it was molecular engineering paired with celestial choreography. Next time you see medieval glass glow, remember, you're not just looking at colored panes, you're witnessing the birth of chemistry, forged in the fires of devotion and preserved in light. Notre Dame de Paris held more than just soaring Gothic arches, it once told time on a celestial scale. Before the devastating fire, its spire functioned as a giant sundial, casting shadows that crept across the square with mathematical precision. On the equinoxes, the shadow would align perfectly with a series of brass markers embedded in the cathedral's plaza, dividing the day into sacred hours. This wasn't just a decorative flourish, it was a working astronomical instrument, a fusion of faith and science where architecture became a bridge between earth and sky. The builders understood something profound, that a cathedral could be more than a place of worship. It could be a clock, a calendar, a mirror of the heavens. Travel 200 miles southeast to Autun Cathedral, and you'll find another celestial cipher carved in stone. The Zodiac cycle adorning its tympanum isn't mere decoration, it's a farmer's almanac frozen in limestone. Each sign corresponds not just to astrological dates, but to agricultural milestones. Taurus for spring planting, Virgo for the first harvest, Capricorn for winter's quiet. Medieval peasants couldn't read Latin manuscripts, but they could read these carvings, following the stars as their ancestors had for generations. The artists even tucked in subtle cues, like the grape-clutching Virgo whose posture shifts slightly year to year, her alignment hinting at ideal harvest times based on lunar cycles. What's remarkable is how these two cathedrals, though separated by miles, shared a common language of celestial alignment. At Notre Dame, the spire's shadow touched specific points only during solstices and equinoxes, moments when the sun straddled the celestial equator. Autun's Zodiac, meanwhile, accounted for the slower wobble of the Earth's axis, with carvings adjusted over decades to compensate for precession. This wasn't guesswork, it was observational science disguised as religious art. Modern astronomers have reverse-engineered these designs and made a startling discovery. The precision matches known solar and lunar cycles from the 12th century. At Autun, the angle of Libra's scales corresponds to the autumn equinox sunlight striking a hidden altar. At Notre Dame, the shadow's path was calibrated to account for Paris latitude, meaning its noon marker was useless just 30 miles north or south. These builders weren't just artists, they were astronomers with chisels, encoding celestial mechanics into every curve and corner. The deeper you look, the clearer it becomes. These cathedrals were medieval observatories. Their spires acted as giant gnomons, their stained glass filtered light into spectral lessons, their floors held meridian lines tracking the sun's yearly dance. Next time you see a zodiac carving or a slanted shadow, remember, you're not just looking at history, you're seeing the fingerprints of a forgotten science where faith and the cosmos spoke the same silent language. Run your fingers along the weathered stones of Rosslyn Chapel, and you'll feel more than rough-hewn edges. You'll trace the ghostly signatures of medieval stonemasons. These aren't just random chisel marks, they're a hidden language, a code left behind by craftsmen who knew geometry as intimately as their own breath. Look closely at the apprentice pillar, its spirals twisting like frozen vines, and you'll spot strange symbols etched between the carvings, compasses, squares, even what some swear are Templar crosses. These marks weren't graffiti, they were blueprints, mathematical puzzles, and perhaps even secret messages meant to outlast the builders themselves. Take the so-called Mason's mark near the chapel's altar, a simple-looking triangle with a curved line cutting through it. To the untrained eye, it's just another scratch, but to a master builder, it might have encoded everything from the angle of a vaulted arch to the proper ratio for mixing mortar. Some marks resemble runes, others alchemical symbols, and a few defy modern classification entirely. The most intriguing cluster appears on the base of the apprentice pillar, where a sequence of interlocking circles mirrors ancient geometric diagrams used to calculate load-bearing weights, a medieval engineering textbook carved in stone. Roslind's pillars tell another layer of the story. Among the biblical scenes and foliage, you'll find carvings of corn and aloe vera, plants native to the Americas decades before Columbus set sail. Some theorists believe these are Templar clues, evidence that knights who supposedly fled to Scotland after the order's dissolution carried secrets of pre-Columbian voyages. Others argue the plants symbolize deeper esoteric knowledge, their placement corresponding to celestial patterns visible only on certain feast days, but the real mystery lies in the chapel's alignment. Roslind's floor plan mirrors Solomon's temple, with key pillars positioned to catch the first rays of the winter solstice sunrise, a feature shared with Templar sites across Europe. At dawn on December 21st, sunlight slices through a narrow window, illuminating a single carved rose on the apprentice pillar. The same light traces a path along the floor, connecting symbols that form a hidden star pattern when viewed from above. Were these codes meant to preserve lost building techniques, maps to hidden treasures, or something far more profound, a visual liturgy for those who knew how to read stone like scripture? The marks remain silent, but their legacy echoes. Every chisel stroke was a word in a language we're still learning to decipher, a testament to a time when craft and mystery were woven into the very bones of sacred spaces. Stand beneath the towering arches of Rheims Cathedral, and you might hear more than echoes of ancient prayers. You might sense the very stones humming with hidden harmonies. The proportions of these sacred spaces don't just follow structural necessity. They resonate with the precise ratios of musical intervals, as if the builders composed symphonies in stone. Measure the width of the nave against its height, and you'll find the ratio of a perfect fifth, the same interval that makes a violin's strings sing when played together. The spacing between columns often mirrors the mathematical leap of an octave, creating visual rhythms that subconsciously soothe the soul. This wasn't accidental. Medieval architects wielded Pythagoras' ancient discoveries like sacred tools, embedding harmonic theory into every load-bearing wall and vaulted ceiling. Take the Chapel of the Holy Cross in Germany, where the length and width form a ratio of 3:2, the exact proportion that produces a musical fifth when plucked on a string. Scholars believe builders tuned these dimensions not just for beauty, but for effect. When Gregorian chants filled these spaces, the notes would interact with the architecture itself, amplifying certain frequencies while softening others. Modern acousticians have recreated these cathedral frequencies using computer models, revealing tones around 110 Hz, a range known to reduce stress and alter brainwave patterns. It's as if the stones themselves were programmed to calm worshippers, using vibrations older than the prayers they housed. But the real marvel lies in how these builders applied Pythagorean principles without modern instruments. They used ropes divided into segments, plucking them to hear intervals before translating those ratios into stone. At Chartres, the labyrinth's path unfolds in sections that match the harmonic series, turning a walk to its center into a physical manifestation of ascending scales. Even the stained glass played a role. Thicker panes at certain heights dampened dissonant echoes, while thinner ones allowed harmonious tones to linger. What's astonishing is how these acoustic secrets were passed down. Guilds of masons guarded these techniques as closely as holy relics, encoding them in geometric patterns and apprentice rituals. Some theories suggest the famous Leonine verses, carved into cathedral walls, seemingly random Latin phrases, actually correspond to musical mnemonics, helping builders memorize harmonic ratios. Others point to the rose windows, whose petal-like segments mirror the intervals of medieval musical notation. Close your eyes in one of these spaces and you'll feel it, a resonance that goes beyond sound. It's the ghost of Pythagorean wisdom vibrating through centuries, proving these cathedrals weren't just built to be seen, they were built to be heard. Beneath the soaring arches of Rheims Cathedral lies another marvel, not of stone or light, but of water. While visitors gaze upward at stained glass, an intricate network of hidden channels carries rain away with quiet precision, a feat of engineering that's preserved these sacred walls for nearly 800 years. These weren't ordinary gutters, they were hydrological masterpieces, designed with slopes so exact that even torrential downpours couldn't erode the delicate limestone. The builders carved grooves into flying buttresses, disguised drain pipes as decorative flourishes, and even engineered underground cisterns to recycle rainwater for washing sacred vessels. But the real genius lies in the details. Some channels were lined with copper, a metal medieval artisans believed had purifying properties. Modern tests reveal a startling truth. Water flowing through these copper-lined channels showed reduced bacterial growth, hinting that these holy water systems may have doubled as early antiseptic networks. Take the cathedral's famed Angel's Gutter, a hidden trough running along the roof's edge. From the ground, it's invisible, just another shadow in the stonework. But up close, its design is revolutionary. The gutter angles downward at precisely 9 degrees, a gradient calculated to prevent debris buildup while minimizing splashback, protecting delicate carvings from water damage. Even more remarkably, its joints are sealed with a mortar mixed with crushed oak gall, a medieval waterproofing technique that outlasts modern synthetics. Similar systems appear at Chartres and Amiens, where copper-lined downspouts terminate in gargoyle mouths, not just for spectacle, but to aerate the water, enhancing its purported purity as it fell into collection basins below. Then there's the mystery of the labyrinth drain. Beneath Rheims' nave, a spiraling channel paved with smooth stones directs groundwater away from the foundations. During excavations, archaeologists found layers of charcoal and sand packed beneath a primitive but effective filtration system, suggesting builders understood water quality long before germ theory. Some scholars argue these features weren't just practical, they were theological. Water, after all, symbolized baptism and renewal. By engineering its flow, medieval craftsmen turned the cathedral into a living metaphor, a mountain where, like the rivers of Eden, sacred and pure waters sprang forth. What's astonishing is how these systems remain functional today, outlasting modern drainage solutions. While contemporary buildings replace gutters every few decades, Rheims' originals endure, their slopes still perfect, their copper linings still inhibiting microbial growth. The next time rain dances on a cathedral's roof, listen closely. That whisper isn't just weather. It's the voice of medieval engineers still teaching us how to harmonize stone, water, and time. Look closely at those stone creatures clinging to cathedral eaves, their tongues lolling, their mouths agape as if frozen mid-snarl. These gargoyles weren't just medieval nightmares carved in stone. They were ingenious water management systems disguised as art. Each grotesque gaping mouth served as a precision spout, directing torrents of rainwater away from fragile walls with the efficiency of modern downspouts. But their genius goes deeper than drainage. The angle of a gargoyle's throat, the curve of its lips, these weren't arbitrary. Master builders shaped them to control water's speed and trajectory, preventing erosion that could undermine sacred stone. Take the famous gargoyles of Notre Dame. Their elongated necks aren't just dramatic flair, they create suction, pulling water away from the building's face with physics medieval craftsmen couldn't name but understood intuitively. During heavy storms, these stone sentinels transform into hydraulic instruments, their yawning mouths whistling with the wind, a phenomenon locals once believed carried storm warnings. Legends tell of a blind monk at Rouen Cathedral who could hear approaching tempests by pressing his ear to a particular gargoyle's throat, its hollow interior amplifying distant thunder like a stone stethoscope. Some carvings hold even stranger secrets. At Freiburg Minster, one gargoyle's tongue curls into a spiral groove, a design that spins rainwater into a tight vortex, scattering droplets harmlessly across the plaza instead of eroding the foundation. Others feature hidden channels behind their eyes, weeping moisture during humidity shifts like stone prophets foreseeing weather changes. The grotesques at Lincoln Cathedral take this further. Their mouths are sized proportionally to roof area, with wider jaws assigned to sections collecting the most runoff, a hydraulic calculation disguised as artistic license. Then there's the legend of the Gargoyle Whisperer. Chronicles from 15th century York speak of a stonemason who could predict hailstorms days in advance by studying the way morning dew collected on specific grotesques. Carvings facing certain directions would weep before weather shifts, their porous stone reacting to atmospheric pressure changes. Modern meteorologists confirm the phenomenon. Limestone's moisture retention actually does fluctuate with air pressure, making these statues primitive barometers. The next time you see a gargoyle's rain-slicked grin, remember, you're not just looking at a monster, you're witnessing medieval hydrology in action, where every grotesque was a weather vane, a rain gauge, and a storm prophet rolled into one. These stone guardians didn't just ward off evil spirits, they outsmarted the elements themselves. Flying buttresses didn't just prop up medieval cathedrals, they performed gravity-defying calculus centuries before Newton penned his laws. Picture a towering wall of stained glass, so delicate it should crumble under its own weight. Now watch as those stone ribs arc outward like the fingers of a giant, catching the thrust of the vault and channeling it down into the earth. This wasn't brute strength, it was architecture as precise as a mathematical equation. The secret lies in the angle of each buttress's lean, typically between 45 and 60 degrees, a sweet spot that transformed crushing weight into elegant vectors. Modern engineers have recreated these designs using computer models, revealing something startling. A buttress angled just 5 degrees too steep would buckle inward, while one too shallow would send walls sprawling outward like falling dominoes. At Beauvais Cathedral, where builders pushed the limits with the tallest Gothic choir ever attempted, the original buttresses failed catastrophically in 1284, sending tons of stone crashing to the ground. The surviving redesign, a masterclass in medieval physics, thicker buttresses with subtle outward curves that acted like springs, absorbing and redistributing stress. Compare that to Chartres, where the flying buttresses look almost too slender to function. Hidden within their graceful arcs is a geometric trick. Each one is slightly thicker at the top than the bottom, creating a parabolic shape that mimics the natural distribution of forces in an arch. It's the same principle behind modern suspension bridges, yet crafted with nothing but ropes and plumb lines. The real genius emerges when you examine the collarbones of these structures, the horizontal connectors between buttresses. At Amiens, these stone rods are tensioned like bowstrings, creating a counterbalance that stabilizes the entire system. Some even feature subtle notches where medieval builders adjusted the tension over time, fine-tuning the cathedral's posture like a violinist tuning strings. What's astonishing is how these masons worked without blueprints or load calculations. They understood structural forces through trial and error, passing down knowledge through guild secrets and hands-on apprenticeships. When Rheims Cathedral's buttresses were damaged in World War I, restorers found carved numbers inside ratios indicating how much each block could bear, a hidden safety code etched in stone. Stand beneath these soaring walls today, and you're not just seeing history, you're witnessing the birth of structural engineering. Those flying buttresses aren't holding the building up. They're conducting a silent symphony of forces, turning stone into music and gravity into grace. While sunlight often steals the spotlight in cathedral mysteries, moonlight holds its own enchantments, particularly in those rare sacred spaces where stone and stars perform a silent duet. In the monastery of Santo Domingo de Silos, Spain, a seemingly ordinary limestone altar transforms under the full moon's glow. Embedded within its surface are veins of celestine, a phosphorescent mineral that absorbs sunlight by day and emits an ethereal blue shimmer by night. On specific lunar phases, this glow aligns perfectly with carvings of the Virgin Mary, making her appear to float in a pool of moonlit radiance. Monks once called it the altar that remembers daylight, using its gentle luminescence to guide midnight prayers without disturbing the sacred darkness. The phenomenon isn't unique. At Burgos Cathedral, a statue known as the Lunar Madonna undergoes a metamorphosis under moonlight. Carved from a rare variety of gypsum infused with selenite crystals, her robe shifts from alabaster white to a translucent silver as lunar light penetrates the stone's fibrous layers. During a waxing gibbous moon, the crystals refract light at angles that make her outstretched hands appear to gather luminosity, as if drawing celestial energy into her palms. Restoration studies revealed the statue's base contains crushed moonstone, a deliberate addition by medieval artisans who understood how certain minerals responded to lunar cycles. But the true masterpiece lies in Leon's Santa Maria de Rigla. Here, a hidden chamber behind the choir houses a mosaic of lapis lazuli and fluorite tiles arranged in a star map. On the night of the winter solstice, moonlight filters through a narrow slit in the vault, striking the fluorite sections with enough intensity to make the constellation Orion glow with an otherworldly green hue, a phenomenon locals once called the breathing of the saints. Modern geologists confirm the tiles contain traces of willemite, a zinc silicate that fluoresces under ultraviolet light, suggesting the builders may have known moonlight carried subtle UV properties centuries before their scientific discovery. These weren't accidents of geology, they were acts of celestial choreography. The same monks who painstakingly charted solstice sunlight also tracked lunar nodes, the points where the moon's path crosses the ecliptic. At Worms Cathedral in Germany, a lunar target carved into the cloister floor only gathers water droplets on nights when the moon is at perigee, its closest approach to Earth. The concave stone collects condensation from the humidity surge caused by the moon's gravitational pull, a phenomenon medieval scholars attributed to divine intervention, but modern science recognizes as tidal force influencing microclimates. What's haunting is how these effects required generational patience. Builders might have tested mineral samples for decades before embedding them, observing how moonlight interacted with stones across full Saros cycles, the 18-year period when lunar phases repeat. The Lunar Madonna's selenite veins, for instance, only achieve full transparency during moonrises in late autumn, suggesting her creators calibrated the statue's placement to coincide with harvest festivals. Stand in these spaces under the right moon, and you'll witness more than clever stonework. You'll see a dialogue between earth and sky, carved by hands that understood night itself as sacred canvas. The stones remember, the light returns, and the ancient conversation continues, one luminous whisper at a time. Beneath the soaring arches and radiant stained glass lies a world few ever see, a shadowy labyrinth of tunnels winding like veins under the very heart of medieval cathedrals. At Bourges in France, visitors marvel at the celestial beauty above ground while beneath their feet, a maze of crypts and passageways sprawls unseen. These weren't just storerooms for relics or wine barrels. They were the cathedral's hidden nervous system, pulsing with secrets. Some tunnels led to nearby monasteries, allowing monks to move unseen during times of siege. Others opened into vast subterranean chambers where barrels of wine aged in perfect silence, their wooden staves stamped with symbols modern scholars still struggle to decipher. One such chamber under Burgess holds a peculiar feature, a series of iron rings embedded in the ceiling, their purpose lost to time. Local legend claims these rings once suspended glass vessels where alchemists distilled mysterious liquids by candlelight. The walls bear scorch marks in strange, spiraling patterns, as if flames were deliberately guided along specific paths. Manuscripts from the 15th century mention the underground fire of Burgess, where blue flames reportedly burned without consuming their fuel, a phenomenon alchemists associated with the elusive philosopher's stone. Could these tunnels have been laboratories for experiments that blurred the line between chemistry and mysticism? Then there are the lights. For centuries, caretakers and pilgrims have reported flickering glows drifting through sealed-off passages, as if phantom lanterns bobbed along invisible hands. Scientists have theorized these ghost lights could be bioluminescent fungi or pockets of phosphorescent gas, yet no conclusive evidence explains their sudden appearances and disappearances. At Chartres, a tunnel called the Chemist's Walk is said to illuminate briefly during the summer solstice, casting shadows that don't match any known physical obstructions. The most haunting account comes from a 12th century scribe at Canterbury, who described an underground chamber where the very walls emitted a faint, pulsating glow. Modern explorers using spectral cameras detected residual traces of radioactive isotopes in the stone, not enough to be dangerous, but enough to suggest medieval builders might have incorporated minerals with properties they didn't fully understand. Were these phenomena accidents of geology, or did the architects of these cathedrals possess knowledge we've yet to rediscover? Walk the dimly lit corridors beneath Burgess today, and you'll feel the weight of centuries pressing in from every side. The air carries a metallic tang like old coins or dried ink, and the walls whisper with the echoes of footsteps that haven't fallen here in lifetimes. These tunnels weren't just functional, they were the silent partners to the glory above, holding the stories too strange, too sacred, or too dangerous to carve into the light. Chartres Cathedral sits atop what locals once called the Sacred Hill, a mound long venerated before Christianity arrived, where ancient druids reportedly worshipped at a spring said to hold healing powers. Modern dowsers who have mapped the area describe intersecting underground water channels beneath the cathedral's foundation, their paths aligning eerily with the cathedral's geometric center points. This isn't coincidence. Medieval builders often constructed sacred sites over these telluric energy lines, places where the Earth's magnetic fields were believed to converge with unusual intensity. At Chartres, the labyrinth center marks the exact spot where two such currents cross, a phenomenon some researchers link to heightened states of awareness experienced by pilgrims who walk its path. Look up at the cathedral's north porch and you'll spot a series of enigmatic carvings, hooded figures with serene faces, their eyes wide as if frozen in revelation. Locals call them Templar heads, though their origins remain fiercely debated. Unlike typical saintly statues, these faces lack halos or identifying symbols. Instead, they're positioned at precise intervals along the porch, their gazes fixed not on worshippers below but on distant points along the horizon. Some scholars suggest they're celestial markers, their sightlines aligning with solstice sunrises or key stars visible in the 12th century. Others note their resemblance to carved heads found at Templar sites from Jerusalem to Scotland, where similar figures guard entrances to underground chambers. The most compelling clue lies in their placement. Infrared scans reveal hollow spaces behind several of these carvings, small niches that might once have held relics or scrolls. At least one head has a discrete slot at its base, its edges worn smooth, as if objects were repeatedly inserted and removed. medieval chronicles mention the Keepers of the North Door, a cryptic group tasked with maintaining certain hidden instruments related to the cathedral's alignment. Were these carvings more than decoration? Could they have served as access points to hidden knowledge, or even as symbolic guardians of the energy lines beneath? Then there's the matter of the Black Madonna enshrined in Chartres crypt, a dark wooden statue believed to stand atop the original Druidic spring. Pilgrims for centuries have reported feeling warmth or vibrations when touching her pedestal, a phenomenon modern geologists attribute to the underground water's movement through magnetic basalt deposits. The Templars, known for their reverence of Marian figures, may have intentionally preserved this pagan-Christian fusion, recognizing the site's unique properties. What's undeniable is the precision with which Chartres harnesses its location. The cathedral's axis aligns not with true east, as was typical, but with the sunrise on the feast of the Nativity of Mary, a date coinciding with ancient harvest festivals. The labyrinth's path unfolds in 11 circuits, mirroring the number of days between solstices and equinoxes in certain medieval calendars. Even the famed blue windows seem to intensify in color during periods of heightened geomagnetic activity, as if the very glass reacts to unseen forces. Whether these connections point to Templar secrets or simply medieval builders attuned to the land's subtle energies, one thing is clear: Chartres wasn't placed by accident. It's a living puzzle, its stones whispering of a time when architecture wasn't just about reaching toward heaven, but about channeling the earth's own hidden pulse. Lincoln Cathedral's mortar shouldn't exist, at least not by modern standards. 800 years of English rain, frost, and wind have barely touched its binding strength, while contemporary concrete crumbles within decades. The secret lies in its recipe, a lost alchemy of lime, sand, and something medieval masons took to their graves. Recent lab tests revealed traces of proteins woven into the mortar's crystalline structure, their molecular fingerprints matching egg whites. Not just any eggs, either. Chronicles from the building's era mention cartloads of hen's bounty, delivered from nearby monasteries, where chickens were fed a diet rich in herbs like nettle and comfrey. When mixed with slaked lime, these organic additives created a mortar that didn't just harden, it healed. Microscopic analysis shows the protein fibers act like a skeletal framework, allowing the mortar to flex slightly during temperature swings without cracking, while also sealing small fissures with a natural calcium carbonate buildup over time. Then there's the volcanic connection. X-ray diffraction patterns detected flecks of pozzolan, a silica-rich ash from Mount Etna's eruptions embedded in Lincoln's choir walls. This wasn't local. Medieval trade routes stretched from Sicily to England, with monks bartering volcanic ash as the dust of angels for its legendary strength. When mixed with lime, pozzolan triggers a chemical reaction called pozzolanic hydration, forming a cementitious gel tougher than modern Portland cement. The irony: Roman engineers used the same technique in their aqueducts, but the knowledge vanished after the empire's fall, only to resurface unexpectedly in medieval Lincoln. The real mystery is how these builders stumbled upon such precision without chemistry labs. A 15th-century manuscript from Lincoln's library describes masons testing mortar blends by pressing thumbprints into wet samples, the depth of the impression supposedly indicating future durability. Another mentions adding ox blood during full moons, though forensic studies found no hemoglobin traces. What they did find were hollow microspheres in the mortar's tiny air pockets that expand during freezing, preventing ice from splitting the stone. Modern engineers call it entrained air, a technique patented in the 1930s, yet here it is in a cathedral built when Genghis Khan still ruled. Most astonishing is how these materials work together. The egg proteins slow the curing process, allowing the pozzolanic reaction to fully mature over years rather than weeks. The result, a mortar that gains strength with age, its chemical bonds tightening like a stone fist. Recent attempts to replicate it have fallen short. Modern eggs lack the medieval chicken's herb-enriched diet, and today's porcelain is mined differently. Lincoln's mortar remains a silent rebuke to our assumptions, proving sometimes the oldest solutions outlast the newest technologies. Next time you see a crumbling modern sidewalk, remember, 8 centuries ago they built better. And we still don't know all their secrets. High above the pilgrim's path, cathedral spires did more than inspire awe. They served as celestial compass needles, guiding travelers across treacherous landscapes under star-strewn skies. At Mont Saint-Michel, rising like a stone ship from Normandy's tides, the abbey's central spire aligns perfectly with Polaris when viewed from key approach routes. This wasn't poetic coincidence, it was medieval GPS. Pilgrims navigating by night would watch for the moment when the North Star appeared to crown the spire's tip, signaling they were on the true path. Even in fog, the spire's silhouette against moonlight provided orientation, its distinctive lantern tower acting as a maritime lodestar for coastal travelers. Beneath those soaring towers, hidden mosaics held even clearer directions. The Star of the Sea in Mont Saint-Michel's cloister isn't just a symbolic title for the Virgin Mary, it's a literal star chart. Tiny brass inlays mark 7 key constellations visible from the bay, arranged in a pattern that mirrors their positions during the autumn equinox. Sailors approaching at night could hold a weighted string from the mosaic's center, aligning specific star markers with the real sky to determine their bearing. The mosaic's outer ring contains 12 silver dots, matching the number of tidal cycles between safe crossing windows in the surrounding quicksand. What looks like decorative flourishes in the cloister's stonework reveals itself as a cipher for safe passage. Diagonal grooves in the floor stones point toward submerged rock formations, while carvings of fish along the arches indicate seasonal fishing grounds where ships could anchor safely. Even the abbey's famous ramparts play a role. Their crenellations are spaced at intervals corresponding to nautical miles, allowing experienced travelers to estimate distances by counting notches against the horizon. The true masterpiece lies in the pilgrim's step, a worn stone near the entrance carved with what appears to be simple geometric shapes. Under moonlight, these shapes cast shadows that align with specific spire features to form an arrow, one that points toward Rome during springtide when most pilgrimages began. Modern astronomers confirmed the alignment only works when moonlight refracts through a particular stained glass window above, proving medieval builders accounted for atmospheric distortion centuries before telescopes. These weren't just pretty symbols, they were survival tools encoded in sacred geometry. When the tide swallowed the causeway and fog blinded the path, pilgrims could still find their way by reading the cathedral itself, a stone atlas written in stars, shadows, and the silent wisdom of those who built bridges between heaven and earth. Look closely at the weathered carvings along Salamanca Cathedral's facade, and you'll spot something that shouldn't exist: a figure clad in what looks like a futuristic spacesuit, complete with a ribbed helmet and what might be breathing apparatus. It's not graffiti, it's not a prank. This astronaut was deliberately chiseled into the stone during a 20th century restoration, yet it's far from the only medieval carving that defies explanation. Scattered across Europe's sacred walls are figures holding objects resembling telescopes, knights grappling with dragon-like machines, and even what some swear are depictions of helicopters or submarines. These aren't just artistic quirks, they're a silent debate carved in stone, leaving us to wonder, were medieval artisans embedding glimpses of the future, or were they playing an inside joke that's lasted centuries? Take the Dragon Slayer capital at Vézelay Abbey in France. At first glance, it's a classic biblical scene until you notice the creature's wings are studded with what look like rotating gears, and the saint's lance pierces not flesh but a series of interlocking rings resembling an archaic engine. Nearby, another carving shows a monk peering through a tubular device pointed skyward, strikingly similar to early refracting telescopes, instruments supposedly invented 3 centuries later. Could these be coded warnings about forbidden knowledge? Some scholars point to 12th century texts mentioning mechanical beasts guarding hidden libraries, suggesting these carvings might have served as cautionary symbols for initiates into certain guilds or orders. Yet other examples hint at something lighter, a medieval sense of humor frozen in stone. In Zurich's Grossmünster, a mischievous gargoyle grins while clutching a distinctly un-medieval object, a crude but unmistakable likeness of a corncob, a plant unknown in Europe before Columbus. At Canterbury, a hidden misericord under a choir stall depicts two rabbits wielding swords, a playful jab at local rivalries between monastic orders. Even the famed astronaut of Salamanca has a plausible explanation. The restorer added it as a whimsical signature, following an old Mason tradition of slipping contemporary elements into ancient works as a nod to future generations. The most compelling theory bridges both interpretations. Many of these carvings cluster near guild halls or stonemason lodges, often depicting tools or concepts relevant to their secretive crafts. The helicopter at Pavia's Cathedral, a symbolic representation of Pythagorean harmonic theory, with its interlocking blades mirroring geometric ratios used in acoustical design. The submarine in a Spanish chapel, possibly an allegory for baptismal rebirth, its portholes echoing early Christian fish symbolism. What seems like anachronistic technology might instead be visual metaphors, inside jokes for those who understood the deeper meaning behind the chisel's stroke. One thing is certain, these carvings were never meant to be taken at face value. They're a dialogue in stone, whispering across centuries to those who know how to look. Whether warnings, jokes, or something far more profound, they remind us that medieval artisans saw their work not just as decoration, but as a language waiting to be decoded. The next time you pass a strange cathedral carving, lean in close. That smirk on the stonemason's dragon, it might just be the punchline to a joke 800 years in the making. Some chapels don't just echo with prayers, they hum with frequencies that seem to vibrate through your bones. Step inside the so-called singing chapel of Burgos Cathedral, and you'll feel it before you hear it, a subtle, resonant thrumming around 111 Hz, a tone modern researchers call the sacred frequency. This isn't just ambient noise. When scientists measured the acoustics here, they found something astonishing. The chapel's dimensions, stone composition, and vaulting create a perfect resonance chamber for this specific frequency, amplifying it naturally without any artificial sound sources. Play a recording of a chant at this pitch, and the walls themselves seem to join in, sustaining the note longer than physics should allow. What's truly remarkable is what this frequency does to the human brain. Studies at Burgos and similar chapels show that exposure to 111 Hz triggers a shift in brainwave patterns, nudging listeners into a state between wakefulness and meditation, the same state monks describe during deep contemplative prayer. EEG scans reveal decreased activity in the brain's language centers, coupled with heightened awareness in areas linked to spatial perception and empathy. Some participants report sensations of weightlessness or expanded consciousness, as if the stone itself were guiding them into a trance. Listen closely to this recording. Hear how the tone seems to bypass your ears and vibrate directly in your chest. That's not imagination. At 111 Hz, sound waves interact with the human body's natural resonance, creating vibrations that ancient builders might have associated with the voice of the divine. The magic lies in the chapel's architecture. The walls are lined with a rare porous limestone that absorbs higher frequencies while amplifying lower ones, effectively filtering out distracting noises and isolating the sacred tone. Even the frescoes play a role, their plaster layers tuned to reflect sound waves at angles that reinforce the frequency. Modern architects have tried replicating this effect with computer models, but Burgos' natural acoustics remain unmatched. Some scholars believe medieval builders tested stone samples by striking them and listening for the telltale, right pitch before placing them, a technique still used by Tibetan monks when constructing singing bowls. Then there's the mystery of intentionality. Was this resonance deliberate? A 12th century manuscript from Burgos scriptorium mentions the tone that opens heaven's gate, describing monks chanting until the walls answered back. Recent discoveries in the cathedral's crypt revealed hollow chambers beneath the chapel floors, spaces that act like subwoofers, enhancing the bass frequencies. Even the chapel's orientation plays a part. Its alignment with the summer solstice sunrise means dawn light strikes the altar at the exact angle that maximizes the stone's vibrational response. Now listen again as the recording builds. That swelling harmony isn't just singers, it's the chapel itself joining the chorus, a duet between human voices and stone that's been performing for 800 years. Whether by design or divine accident, these spaces prove sound wasn't just something medieval worshippers heard. It was something they felt, a physical bridge between earth and eternity, still humming its secrets to those who pause long enough to listen. Brick by brick, medieval cathedrals guarded their greatest treasures not in ornate reliquaries, but in the hollows of their very walls. The recent discovery at York Minster stopped historians in their tracks. A hidden chamber no larger than a broom closet, concealed behind what appeared to be ordinary stonework. Inside, stacked with monastic precision, were 15 parchment manuscripts from the mid-14th century, their inks still vibrant as the day they were penned. But these weren't typical devotional texts. Page after page revealed intricate star charts, lunar cycle calculations, and diagrams of celestial spheres, an astronomer's toolkit frozen in time. The vellum showed no signs of mold or decay, preserved by the wall's consistent temperature and a clever ventilation system of hair-thin gaps in the mortar that maintained perfect humidity. One manuscript stood out, a codex bound in unusually thin oak boards, its cover etched with constellations that glimmered when angled toward candlelight. Scholars realized the metallic sheen came from crushed meteorite particles mixed into the ink, creating a material that literally fell from the sky to map the heavens. The pages contained predictions for eclipses decades into the future, calculations so precise they accounted for lunar orbital variations modern astronomers only confirmed with satellites. How did medieval scholars achieve such accuracy? The answer lay in the margin's tiny notations referencing the glass that sees the moon's scars, suggesting they used early optical aids long before telescopes were officially invented. These secret repositories weren't accidents. At Salisbury Cathedral, restoration work revealed narrow slots between stones designed to hold scrolls vertically, protected by layers of sheep's wool and beeswax. Exeter Cathedral's famous astronomical clock once hid treatises in its hollow base, accessible only by removing a specific keystone near the spring equinox sunrise alignment. The builders engineered these spaces with deliberate cunning, false mortar lines camouflaging seams, air channels preventing parchment degradation, even iron pyrite flakes embedded in surrounding stones to repel insects with their faint sulfuric scent. The York manuscripts contained another bombshell, folios marked with strange symbols later identified as cipher notations from the Order of the Lilies, a shadowy fraternity of astronomer monks. Their notes describe using cathedral spires as giant sextants, sighting stars through specific window tracery to measure celestial movements. One diagram shows how Lincoln Cathedral's crossing tower framed the pole star through its north transept rose window on winter solstice, a configuration that would have allowed precise timekeeping even on cloudy nights. Most astonishing is what these hidden libraries reveal about medieval knowledge transmission. The scripts show evidence of collaborative corrections, notes in multiple hands updating calculations across generations, proving these chambers weren't just storage but active workspaces. At Wells Cathedral, ultraviolet light exposed erased sketches under later manuscripts, revealing how monks perfected lens curvature diagrams over decades before the technology was publicly known. These walls didn't just preserve knowledge, they protected it. During the dissolution of the monasteries, when Henry VIII's agents were seizing and destroying precious texts, these sealed chambers saved irreplaceable scientific works. The York manuscripts include a poignant marginal note in shaky handwriting. To those who find this, know that true light cannot be quenched by earthly flames. That light still reaches us today, glowing faintly from within stone walls that were never as silent as they seemed. The Black Madonnas of Europe don't just startle with their dark hues, they whisper of an older world hidden beneath centuries of varnish and candle smoke. Step into the crypt of Chartres or the shadowed alcoves of Montserrat, and you'll find these enigmatic figures gazing back with eyes that seem to hold the weight of unspoken histories. Their ebony complexions weren't accidental. Medieval artists deliberately used materials like walnut stain or volcanic basalt to create these sacred shadows. But why? Some scholars trace their origins to pre-Christian earth goddesses, figures like Isis or Cybele, whose worship often involved dark stone idols symbolizing fertile soil and the mysteries of the underworld. When Christianity spread, these potent symbols weren't erased. They were reborn, their forms adapted but their essence preserved in the Virgin's serene face. The Templars, those elusive warrior monks, may have played a role in this transformation. Returning crusaders brought back more than relics from the Holy Land. They carried echoes of Middle Eastern devotion to black meteorite stones like the Kaaba in Mecca or the Diana of Ephesus, a multi-breasted fertility goddess whose statue was said to have fallen from the heavens. In Provence, the Black Madonna of Les Saints Maries de la Mer is venerated by Roma pilgrims who still sing hymns linking her to Sarah La Colle, a dark-skinned saint possibly descended from Egyptian or Indian traditions. The Templars' own cryptic rituals included veneration of a mysterious black head, mentioned in trial records. Could some Black Madonnas be coded references to this forbidden icon? Carbon dating adds another layer to the puzzle. The wood from several statues, like Our Lady of Guadalupe in Spain, predates Christianity by centuries, suggesting they were repurposed pagan idols. At Einsiedeln Abbey in Switzerland, the Black Madonna's chapel stands on the exact spot where a hermit once worshipped a statue of the Celtic goddess Abnoba. Even the miracles attributed to these figures often tie them to the land, springs bursting forth at their feet, crops flourishing after processions echoing ancient fertility rites. Yet the most compelling clues lie in the statue's hidden compartments. X-rays of the Black Madonna of Czeszów revealed a tiny cavity in her chest holding grains of wheat and poppy seeds, offerings straight from Neolithic harvest rituals. Others contain scrolls with Hebrew or Coptic script, hinting at underground networks of knowledge moving between cultures. At Rocamadour, pilgrims still climb the sacred stairs on their knees to touch the statue's robe, just as their ancestors might have crawled to touch the earth itself. Whether earth goddesses in Christian garb, Templar secrets in plain sight, or bridges between worlds, these dark Madonnas defy simple explanation. They stand at the crossroads of faith and folklore, their shadows stretching across time, reminders that the sacred has always been more complex, more layered than the stories we tell about it. In the shadows of Canterbury Cathedral's soaring arches, time didn't tick, it burned. Monks here measured the divine hours not with gears but with flame, using candle clocks so precise they could track prayer intervals to within minutes. These weren't just wax and wicks, they were calibrated instruments, their lengths marked with embedded lead weights. As the flame consumed each marked section, the weight would drop onto a metal plate below with an audible clang, a sonic signal cutting through the silence of the night office. The candles themselves were crafted from beeswax mixed with chamomile, a combination that burned at a remarkably consistent rate, unaffected by drafts thanks to protective horn casings. Records from the 12th century describe a master clockkeeper who adjusted the wax blend seasonally, adding more tallow in winter to compensate for colder air slowing the burn. Wells Cathedral took a different approach, turning water itself into a timekeeper. Their hydraulic clock, restored from medieval manuscripts, used a complex system of calibrated bowls and copper pipes. Water dripped from a raised reservoir into a primary basin where a floating marker rose along a graduated scale. But the true genius lay in the overflow mechanism. Once the basin filled, it triggered a secondary siphon that emptied it abruptly, simultaneously ringing a bell and tilting a figurine of the Virgin Mary to signal the hour. This tipping Mary became legendary among pilgrims who swore the statue moved with supernatural grace. Modern engineers recreated the design and found it accurate to within 15 minutes per day, a feat for the 13th century. The real marvel was how these systems synchronized sacred time across entire regions. At Canterbury, a network of candle clocks in dependent priories was calibrated using sunset observations relayed by horseback. Wells' water clock, meanwhile, adjusted its flow rate monthly based on lunar tables kept in the scriptorium, accounting for the varying length of daylight hours. Both systems shared a common secret. They weren't just measuring time but sacralizing it. The candle's glow mirrored the light of divine wisdom, while Wells' flowing water echoed baptismal renewal. What's often overlooked is the ingenuity behind their maintenance. Canterbury's monks kept a clock garden of herbs believed to stabilize combustion, harvesting lavender and sage to rub into the candles. At Wells, the water source came from a hidden spring channeled through lead pipes lined with crushed oyster shells, a natural filtration system that prevented mineral buildup from disrupting the flow. These weren't crude prototypes, they were precision instruments born from centuries of observation and refinement. The lesson these timekeepers whisper across the ages isn't just about mechanics, it's about perspective. To medieval monks, time wasn't an abstract grid to be partitioned, but a sacred rhythm to be harmonized with. The next time you check your phone for the hour, remember, 800 years ago, they were telling time by the patient dance of flame and water, and doing it with a precision that still humbles us today. Strasbourg Cathedral's famously crooked spire doesn't just defy gravity, it defies explanation. Leaned to one side like a stone titan mid-pirouette, this architectural quirk wasn't born from shoddy craftsmanship but from deliberate genius. Peer up from the square below and you'll notice something uncanny. The spire appears perfectly straight. That slight twist, roughly 15 degrees off-center, corrects an optical illusion caused by the building's asymmetrical facade, compensating for how the human eye processes converging lines at extreme heights. Medieval builders understood visual perception in ways modern architects would only rediscover with computer modeling. But geometry isn't the only secret hiding in that twist. Local legends whisper of a darker purpose, that the spire was designed to confuse evil spirits by confounding their straight path downward. Similar intentional flaws appear across Europe. The intentionally uneven towers of Keen's Abbaye aux Hommes, where one side bulges slightly to counteract wind patterns, or the drunken columns of Pisa's Cathedral, spiraling subtly to mask settlement cracks with artistic flair. These weren't mistakes, they were stone sleights of hand, blending physics and folklore into architectural alchemy. Take the smiling gargoyle high on Freiburg Minster's tower. From the ground, its grin appears jovial until you climb level with it and realize the mouth is a grimace of pain. Perspective manipulation transformed a warning against sin into a welcoming symbol for pilgrims. Even the cathedral's famed labyrinth holds a hidden error. One path deliberately diverges from the sacred geometric pattern, leading to a tile marked with a tiny, forgotten heraldic symbol, possibly a stonemason's coded critique of a long-dead bishop. The most tantalizing twists hide in plain sight. Chartres' north porch features a column that twists like a corkscrew, an anomaly once blamed on medieval incompetence. But laser scans revealed its spiral matches the Fibonacci sequence's growth pattern, a mathematical marvel that wouldn't be formally documented for another 3 centuries. Was this a silent nod to nature's blueprints or a guild secret passed down through generations? Then there's the mystery of the weeping stones. At Lincoln Cathedral, certain vault ribs glisten with moisture even in drought, a phenomenon traced to porous limestone veins deliberately positioned where dawn condensation would highlight them during penitential seasons. Like the crooked spire, these weren't oversights but orchestrated revelations, turning architecture into a dialogue between earth and sky, craft and cosmos. The next time you spot an odd angle or uneven arch, look closer. What seems like a flaw might be an 800-year-old wink from the builders, a message carved in stone waiting for someone to finally understand. Beneath the soaring arches and celestial alignments of medieval cathedrals lies a haunting silence, the absence of names. Unlike Renaissance artists who signed their masterpieces, the master builders of Chartres, Amiens, and Reims vanished into history without signatures, their identities swallowed by time. This wasn't accidental. Medieval guilds operated under strict codes of anonymity, treating architectural knowledge as sacred trust rather than personal glory. But the deeper mystery isn't just their namelessness, it's how their surviving blueprints reveal mathematical sophistication centuries ahead of their time. Examine the weathered parchment plans for Cologne Cathedral, and you'll find curves calculated with precision that mirrors integral calculus concepts not formalized until Newton and Leibniz in the 17th century. The flying buttresses of Beauvais weren't just sculpted by intuition. Their angles follow parabolic equations that modern engineers confirm are optimal for load distribution. How did 13th century stonemasons grasp principles that would elude academia for generations? Some historians point to the Leonardo da Vinci of the Middle Ages, a shadowy figure referenced in guild manuscripts as the master of compasses. Fragmented texts describe a polymath who traveled between cathedral sites, teaching masons to use geometric progressions and harmonic ratios, secrets possibly inherited from Moorish scholars or preserved Byzantine texts. The evidence hides in plain sight. At Strasbourg Cathedral, a hidden workshop ledger lists payments for the silent master's devices, tools resembling early slide rules and proportional dividers. In Lincoln's archives, a marginal sketch shows a mysterious figure demonstrating a pendulum's swing to apprentices, predating Galileo's studies by 300 years. Even more compelling are the coded carvings. At St. Denis, a capital depicts a hooded man holding a tablet marked with what modern cryptographers recognize as early algebraic notation. Yet the greatest clue may lie in what's missing. The sudden leap in architectural sophistication between Romanesque and Gothic styles suggests knowledge transfer from an outside source. Perhaps Crusader engineers who encountered advanced mathematics in the Middle East, or Jewish scholars fleeing persecution who brought Neoplatonic geometry to cathedral workshops. Some blueprints bear uncanny resemblances to diagrams in the lost notebooks of Abbas ibn Firnas, the Andalusian polymath who experimented with flight and crystal lenses. The true genius of these nameless builders wasn't just their skill, it was their humility. They crafted stone symphonies to honor God, not themselves, embedding eternity into vaults and spires while erasing their own footprints. Perhaps that's the final lesson whispered by these walls. Greatness doesn't need a signature when it's written in the very bones of the earth. So there it stands, not just a cathedral, but a grand laboratory of stone and light. Every spire, every stained glass pane, every echoing vault was more than an act of devotion. It was a meticulously crafted experiment in astronomy, acoustics, hydraulics, and geometry. These buildings weren't merely places to worship, they were textbooks carved in limestone, their pages open to anyone who knows how to read them. Think of the master builders who encoded celestial alignments into rose windows, or the monks who tuned entire chapels to resonate at sacred frequencies. This was science wrapped in faith, physics disguised as prayer. Yet the most astonishing part, these secrets aren't locked away in vaults or guarded by scholars, they're waiting for you. Walk the labyrinth at Chartres and feel the Earth's energy humming beneath your feet. Stand in the choir at Lincoln and clap your hands just once, listening as the sound spirals upward like a soul released. Lift your phone to capture the solstice light at Amiens, watching as it ignites carvings that have marked time for 800 years. These cathedrals are alive, still whispering their lessons to anyone who slows down enough to notice. So here's my challenge to you. Visit one, not as a tourist but as a detective. Trace the hidden geometries in the floor tiles. Count the musical intervals between pillars. Watch for the moment when sunlight becomes scripture. Then come back and tell us what you found, because every viewer who shares a discovery adds another piece to this ancient puzzle. The comments aren't just a space for reactions. They're a modern scriptorium where we can collectively decode these stone enigmas. As the drone pulls back from that glowing rose window, its petals radiating like a cosmic clock, remember this: Gothic cathedrals were never meant to be frozen in time. They were built to evolve, to speak across centuries, and right now they're speaking to you. The question is, what will you hear?